Hello friends, welcome back to our channel Neuron, which means watch and learn. And today we are going to share with you the solution for daily coding challenge 4. But before we do, Neuron will give you a philosophical speech. Okay, just kidding. First of all, what I wanted to tell everybody that comparatively daily coding challenge 4 was a bit harder compared to 1, 2 and 3. And many times it would happen that you will come across a problem statement where you don't know the solution directly, or you could not come up with the solution directly as soon as you saw the problem. And as a result, many new programmer who are trying to learn and become better at programming, they think that we are actually dumb. At least for me, I was thinking that I am a dumb when I actually started encountering bit problematic and bit more complex problems, and I was not able to solve it the moment I saw the problem statement. So that's actually a wrong way to tackle a complex problem. First of all, it does take some time and practice to think that how to crack a particular problem. All right, that is the first thing. Second thing, I thought that any problem that I come across, my brain or I should be able to solve it in my own way, right? That is the first thought, and that is actually very counterproductive. What I mean by that is I don't want to look into somebody else's solution thinking that I am a dumb and I am not able, and I should not be allowed to see somebody else's solution, and that's problematic. In that case, I will never learn, and that is one thing I wanted to highlight before I share with the solution with you. And also, frankly, the moment when I saw this problem a couple of years back, I didn't know a better way to solve it. Okay, even I learned from somebody else, and that's how programming world is all about. You keep learning from one person or the other, and there will be a scenario when people will also learn from your solution once you become better at it. Okay, so with that, I think now that we are on the same page, let's start into solving the problem, and which is given a 6 by 6 matrix. I'll just write this way: A B C D E F G H I J K L M N O P Q R S T U V W X Y Z, and let's put them anything, any number, 0 1 9 10 and so on. All right, and what we are going to do here is the way I gave you the hint is we'll try to do a convolution. Okay, and I will show you what convolution means, and for that I'll be using a 3 by 3 matrix. Okay, and because the problem statement says that one, I have to find 16 hourglasses, to find sum of all those 16 hourglasses and the values which comprise of those hourglasses. So for example, if I am taking this hourglass here, then I should take the sum of this particular matrix, and of course J and L will be not considered in this case, in this particular hourglass, and I have to take the sum of D plus E plus F, K plus P plus Q plus R. Okay, all right. All right, so what I next want to do is I want to explain that how convolution method will work. Okay, and for that we need a 3 by 3 matrix, and because I have to eliminate J and L, what I'm going to do is my 3 by 3 matrix would look something like this: 1 1 1. So it will be 3 by 3 matrix: 0 1 0 1 1 1. Okay, now convolution means convolve, right? Which means what I'm going to do is I'm going to take this particular 3 by 3 matrix and I'm going to place it here. Okay, one by one. I'll show you how. So the first place where it will appear is this one. Okay, so what will happen, I will, if I place this 3 by 3 matrix here, so it will be 1 1 1 0 1 0 and then 1 1 1. Now if you consider the small matrix in below, which comprise of A B C G H I and M N O, okay, let me shift to the next page. So what I have, A B C, so I have A B C G H I have M NO, right? Think of that as a very subset of the original matrix, and I have this green matrix, right? So which I have placed it on top of it. So you'll have 1 1 1 0 1 0, then I have 1 1 1. Now if I multiply this together, so what will happen? A times 1, then I can sum them, b times 1 plus c times 1 plus g times 0 plus, you see, g automatically gets eliminated, h times 1 plus I times 0. See, now I also got eliminated, and it makes our computation really fast and easy. And this is the basis for people who are interested in machine learning, how the convolutional neural network works. The first step, which is the convolution part, this is exactly what TensorFlow does for you when you use the conv 2D and 3D methods. So there are methods in convolutional in TensorFlow. There are already ready-made packages which will do these manual calculations for you. There are functions written already, but if you know how it is working underlying, guess what, you have the 50% of the convolutional neural networks is clear to you. Okay, then you have m times 1, n times 1, and o times 1, right? And when you sum them, you get whatever value we have. That means sum them, these two are eliminated. See, this is how we can calculate the sum of an hourglass. Now the question comes, how do I shift, right? So I need to shift my green box, right? So what I will do is, instead of having the green box now here, what I will do next is I'll move my green box by 1 square, and that is called as stride in the terminology of convolutional neural networks. It's called stride. So you move next. Okay, so what we will do is, I'll just make a note of it, BCD HIJ. So you'll have another square BCD, then I have HIJ and NOP. HIJ NOP. And guess what? You must have already guessed it. I'll place the matrix again, 1 1 1 0 1 0 1 1 1, and so on. So what you will get is b times 1 plus c times 1 plus d times 1, and so on, p times 1, and you take the sum, you'll see this is eliminated, this is eliminated, and you got your hourglass. Now this is horizontally, of course. So what you are going to do is, you're also going to shift it down, then continue again horizontally, okay, and horizontally and horizontally. This is a mess I'm creating, but you got the point, right? All right, so let's take a blank screen. Okay, so now that we know what convolution is going to do, what we need to figure it out, now that we understood that we are going to take a small subset from the six, say if this was a 6 by 6 matrix, then I'm going to take a small subset of it, multiply it the same matrix with a filter in terms of so what you're going to do, we're going to take a 3 by 3 filter or window. That is what is called in terms of convolutional neural network, and this window is nothing but 1 1 1 0 1 0 and 1 1 1. Okay, and your subset, which is the red box, will be the original value. In this case it will be H A B C D E F, maybe what it was, if you recall, G H I and so on, right? G H I M N O. So this was the subset of your 6 by 6 matrix, right? Because there are other elements here in the original matrix. So what you're going to do, we are going to take a convolution between these two matrices, and you get your sum. So that will be one of the sum. Likewise, there are 16 such windows that will appear, and you will get 16 sums. Okay, now the next question that might come is, how did I come up with 16 numbers? How do I know that a 6 by 6 matrix will create a 16 such hourglasses? The reason being, because we are using a 3 by 3 filter, I will represent with one of them as F, and say this is my original value. So the formula that creates is how many hourglasses will be there. So I will say Hg is given by a formula which says O minus F, okay, divide by the number of strides. So remember, we were moving from one window to one window, so basically we are taking only one step at a time. So divide by stride, which is 1 at this point of time, plus 1. So if you see, 6 minus 3 divide by 1 plus 1 is equal to 4. And because we are repeating it in a 2D, so it will be 4 by 4, and that is why we'll have 16 hourglasses. Okay. In the original convolutional neural network, there is also something called as 2 times the padding, because we are not going to use padding in this 6 by 6 matrix, and padding are typically used in images. So you can consider this as a 6 by 6 image. This is a different concept which is not required for this particular problem statement. Okay, this is the first part. Let's now think about how we can all right, take this method and apply it in our original matrix. Okay, so G H I J K L M N O P Q R S T U V W X Y Z da 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 da. Okay, now we need to build a logic so that I'll represent this 1 1 0 0 1 0 and 1 1 1 as a W. Okay, now I have to come up with a loop so that I'm able to cover my entire matrix. So I'll start from, sorry, I'll start from this particular square, then I will move to my next one. Once I have taken the sum, then I will move to third and so on. Okay, and also I'll have to move vertically. So eventually this was the starting point, but eventually I'll come down to this place and so on, right? And then I'll move horizontally, and finally I'll come and so on. All right. Okay, now how do I create a logic for this? Okay, what will come handy is the number of hourglasses, and that is obviously 4 by 4. These numbers are very important for us because, and even in CNN, that is why CNN became very popular method to solve image processing problem using neural networks, because we don't have to worry too much about the size of the image, because if we having a constant size filter, the one that I have explained here. Okay, and we'll explain that later once you follow our convolutional neural network playlist, which is coming up. Okay, all right, so first of all, this is a important number for us. So what we are going to do is we are going to run a for loop which will take this as first input and this will take as second input. Why do we have 4 here? That is very important question, because if you count, this is my first, so this is my 1, this is my 2 in the next step, this is my 3 in the next step. So basically I can slide my window only 4 times horizontally, right? And also if you see vertically, this is my second, this is my third, and eventually this will be my fourth. So also in this direction I can only go 4, and in this direction I can only go 4, and that is why we'll eventually get 16 hourglasses. See, now that does that make clear? Okay, now let's build a logic. Okay, what we are supposed to do is, so keep this in mind. Okay, so we have 1 1 1 1 1 1, and then we have, okay, keep this picture in mind, we have a 6 by 6 matrix. So the first for loop is for the horizontal one. So I'll say for horizontal I'll use the H just for easy representation. For H in range 4, and when I say 4, basically you're traveling from 1 0 1 2 3 in Python. Okay, that's why 4. This is for the horizontal part, and then I have to go vertically down. So again the second loop will be for width. So typically in CNN we also call as height and width, so I'll continue using the same notation. For I in range 4. Okay, so this is my logic for the for loop. So it will go horizontally this way and vertically this way. Next we have to prepare some variables so that I can tell my filter, which was a 3 by 3 matrix, and it knows how to travel the way I mentioned just in the slide before. Let's continue from there. Alright, so once we know from where to where we should be running our for loop along the horizontal and vertical direction, now we need to set up some variables so that our 3 by 3 matrix knows where to start and where to end. So if it is a 3 by 3 matrix, we know that it has to start right from the first value, right? And it should take into account the first 3 element here and all these 9 elements together, right? So that means it should start here and end here vertically, and it should horizontally, it should also start at the same point but end here, right? Okay, so that is what we are going to do. That is what we are going to find. Okay, so what we are going to give a name is, say, vertical start will be equal to, so anyways our h will start from 0, right? Oops, sorry. Or h will start from 0, and also w will start from 0, right? So once h is 0, so that means I'm already here. So that means vertically I can have the value h directly. And where my vertical end will happen? Vertical end is nothing but this h, or you can say, for the timing you can say vertical, oops, no, sorry, my bad, I'm taking it back. My end, vertical end will be wherever my start plus 3, because my height of my window or filter is 3. Okay, the logic is clear now. And same for the horizontal, so I can go horizontal start equal to, guess what, because in our case h and w have the same value, which is 4 by 4, so I can use w here. You can also use h, but then we have the same value and we are going to run in both the sides, so that's, it's better we keep them separate. So we'll have h and w separate. Alright, and then we have the horizontal end is equal to the horizontal start plus 3. Okay, so that means it ends here, okay, in the first loop, and so on. So what will happen is, as the loop continues, this square, so when h becomes 1, right, so it will horizontally, it will shift by 1 and the process will continue. This is the same simple logic. That is all we need. Now the interesting part comes, and that is, now that we know the start and end, so we have the start and end for vertical, and then we also have the start and end for the horizontal. Now what we can do, a very simple method, is we are going to take the original array and say the original array is represented by, say, ARR. So my original array is ARR, so I can take a slice of it, because I need for multiplication, right? Because if I have to multiply with a 3 by 3 matrix, I also need to make sure my columns, this value and this value are matching, this value and this value are matching, right? The traditional rule for matrix multiplication. And so I can take a slice. What I can do is I can say vertical start colon vertical end comma horizontal start colon horizontal end, right? And that's it. And this is my, this slice, the first slice here of 9 elements, and to this I can multiply my window, which is my, and say it is represented by w, right? So I can just do a w. Okay, so what we have is w times your original array times, and this I need to take a slice, so it will be vertical start to vertical end comma, and then horizontal start colon horizontal end. Okay, and now because I have to take a sum, I can use the NumPy library and p dot sum. Okay, now next what? Okay, what we are supposed to do is when we are doing a for loop and while we are creating a function, if we create a simple list, an empty list, what I can do, because I know there will be maximum 16 sums only, so I can use an empty list, and what I can do is I can store all these sums. Now by this time, by solving 1, 2 and 3, you already know we are going to use an append function, right? And we can put this sum inside that, right? You can put this sum whatever it comes, and if you are, if all these equations are inside a function, then you can just say return maximum of these sums, and it will return the maximum sum. That's it, man. I mean, once you have enough practice, these solutions will come obviously to you, automatically to you, so you don't have to worry about it. And but coming with this logic needs a lot of practice, and that is why it say you, if you are following our Mirror Neuro channel, please do follow from Daily Coding Challenge 1, and I promise you by the end, we are targeting to post 100 problems. So by the end of 100 problem, you'll definitely become very good at programming, and all these logics you can apply it in all the problem statement that you come across, either it is machine learning or data science or you're doing automation. We'll put a lot of links in the description section so that you can solve it. Now can you pause this video and try to write the code on your own? I have already explained the logic. Pause it wherever you need, write the logic, see whether you can write it perfect, accurately or not, can you able to run it or not. And then if you cannot, still if you cannot, just watch the video again to understand the concept, and we'll also post the code in this video itself, so you'll also be able to see the code itself in the Google Colab. So but I definitely encourage you to pause this video right now and try to write the code on your own, because that is the essential key. If you see, if you only watch solutions, that will be not enough. You have to think hard and then correct yourself by looking at solution. Not directly watching solution will help you at all. So pause the video and try to solve it yourself, or you come back and watch the solution.